Question 6.8 is on areas of triangles and quadrilaterals. You've done a lot of this. So you know the area of a square is side squared, right? Have you all seen that? The area of a rectangle is base times height, or length times width, right? The area of a parallelogram, do we know this?
And base times height.
Yeah, it's base times height as well. Area of a triangle?
Half base times height.
1/2 base times height, exactly. But do we know where some of these come from? So the area of a parallelogram. So the reason that it's just the base times height is because if I take this little triangle here and I cut it off, so imagine I'm taking my scissors and I'm cutting it, and then I put it over here, do you guys see how this distance is still b, this distance is now h? Well, it's still h. So we have a rectangle. That's all we're doing. We're cutting part of the parallelogram off, and we're moving it, so it creates a rectangle. Easy enough? All right, so where does the area of a triangle come from? Well, it kind of comes from that. So if I have my base times height and I start cutting things, and I decide that I want to cut something, where do I want to cut it? I'm forgetting how I proved this to myself before. I think I want to cut it right there. What do I do here? Okay, and then I move it over here. Is that what I want to do? What am I doing here? Okay. I know, what am I doing? I'm trying to cut it so that it's 1/2 base times height. So I have my, I think I just did this picture terribly. I think I meant for this to be a parallelogram, and this picture is just awful. Okay, so let's make this. So do you guys see this right here? What if I add it to another triangle that's exactly its size? Right there. Do we see it?
Yeah.
Do we get a parallelogram?
Yes.
What's the area of the parallelogram? Base times height, right? So what do we have? We have half that picture. So the area of our triangle is half of a parallelogram, which is half base times height. I think I just needed to draw a little bit extra in there. That would help. All right, does this make sense? So make it into a parallelogram. So if I have a triangle like this, I can create a parallelogram, and I can say, oh, it's just going to be the base times this height, right? For the whole parallelogram. And then you say, but I only have half of it, so I have this much. That's what I was trying to say there. Okay, next up. So the area congruence postulate. So if two polygons are congruent, then surprise, surprise, they have the same area. Exactly. And this leads to the area addition postulate, which says the area of a region is the sum of the areas of its non-overlapping parts. So you guys have seen this before, where you have maybe a square with a semicircle on top of it and a triangle on the side, and you have to find the area of the total figure. Okay, that's what we're going to do. So we're going to find the area of the whole figure. So in this first one, it says find the area of triangle ABC. So be careful. I always think about it as a cliff. We've talked about this before. If I have this cliff, the height of the cliff is right here. So my height is 6. Oops, h is 6. What's my base? The base is just here.
11.
Yep. So my area is going to be 1/2 my base times my height. I always find the easiest ways to multiply these, so I would probably do the 1/2 times 6 first and get 3. Did you guys spill a bunch of stuff?
Yeah, okay.
There's some, use the towels from the whiteboards. So we get 3 times 11, which is 33. So it should be 33, and then what units do I use for area in this case? Centimeters squared, exactly. Okay, make sure that they have the same units. So maybe you have inches and then feet. You have to change things all to inches or change things all to feet, right? All right, so it says find the base of a triangle that has an area of 48 square feet and a height of 3. Well, we can use 1/2 base times height, and we can say our area is 48 when our height is 3, and we solve it out. One step at a time. If I get rid of that 1/2 and take it to the other side, what does the left-hand side become? 24? 96? Why is it 96, Joseph? You're correct. Yeah, we want to get rid of the 1/2 by multiplying both sides by 2, so it becomes 96. So we're dividing by 1/2, which is the same as multiplying by 2. So I get 96 equals b times 3, or 3b. So when I divide by 3, I get b is equal to 32, exactly. And this would be in feet, right? So make sure you put your units on Mr. Crawley will be very happy if you put units. Units are the key to life, he always says.
Oh, Mr. Crawley said you don't like sig figs.
Oh, yes, I don't. Because AP Calc is always 3 decimals no matter what, so we don't do sig figs in AP Calc. So, all right, so find the area of the parallelogram shown. I mean, I get why we use sig figs in real life.
It'll make more sense.
It's not that I don't. I'm not against sig figs. I just don't like it in the math classroom because in AP Calc, you get counted off. All right, so find the area of the parallelogram. Shh. So our area is base times height. Can you identify what the base is and what the height is?
2.5.
Yeah, our 2.5 is the base, right? And our height is not what we call the slant height. It's not the slanty one.
It's the 1.8.
It's the one that directly is between the two bases, right? So it's 2.5 times 1.8. So you can do 2.5 times 1.8, and we get 4.5. Units?
Meters squared.
Yep, because it's an area. Good. So the last one was just feet because it was just a length. It wasn't the whole area. All right, so now we have one of these like composite figures, as we call them. So we have all these pieces that are not overlapping, so we're going to try to break it into non-overlapping pieces. So if the whole thing from here to here was 6, but then this distance, you see what I'm drawing in blue? Maybe I shouldn't use blue since the whole figure is blue. This distance was 2. Can we get other pieces? I don't know. This distance was 3. What about this one then? I would say that's 3, right? Does that make sense? So do we have 3 rectangles or 3? Well, one of them's a square, but it's still a rectangle. So let's do this first area. What's this first area on the bottom one? 27, right? 9 times 3. What about the left, top left?
6 or 8.
2 times 4 is 8, yep. And then what about the right one? 9. So we add them together, so we have 8 plus 9 plus 27. So our total area is 17 plus 27.
44.
Yeah, which is 44. So 44 centimeters squared. Easy enough? All right, so the area of a trapezoid we actually do all the time in my AP Calc class. All the time. Because we do something called the trapezoidal rule. So I always tell my coworkers, I'm like, we could totally teach some AP Calc concepts in geometry. So maybe I'll show you a trapezoidal rule sometime. It's not hard. You guys could totally do it. So the area of a trapezoid, though, has a formula that's a little hard to understand, a little hard to remember, I guess. But if you remember the trick on how we got it, you will always remember this formula. So everybody look up here. Do you guys see our picture? Imagine I gave this to you and I gave you scissors, which you all have. We're not going to cut it out of our notes, though. So here's where I'm going to cut. I'm going to cut straight down here, and I'm going to cut straight down here. And what's going to happen is it's going to cut off this little triangle on the right side, and it's going to cut off the triangle on the left side. And then I'm going to move those. So this triangle is going to get moved. Where do you think? Right here. Right? And this triangle right here is going to get moved. Where is it going to get moved? Right there. Okay, and what shape do we have now?
Rectangle.
A rectangle. And that rectangle has a certain base and a certain height. Now the height is still h. So whatever your height was before, it's still the same height. But the base has changed. It's not B1 and it's B2. How do you think it's going to be related to the B1 and the B2? Give a guess. So if the B1 was 10 and the B2 was 16, let's say. If I had one height or one base was 10 and the other one's 16, what do you think the one that was in the middle is going to be? It ends up being the average. So what do I get when I add 10 and 16 and then divide by 2? I get 13. It's going to be the average of those two. Is 13 directly between 10 and 16? Yeah. Okay, so this segment here is called the mid-segment. And the mid-segment is directly in between the two bases. So basically, like if I had, a trapezoid like this, here's a midpoint right here, and here's a midpoint right here. If I connect those two midpoints, that's called the mid-segment. Does that make sense? And that mid-segment is the average of the bases. So that's what I mean by 1/2 the sum of the bases. But it's not really 1/2 in the sum of the bases altogether, right? It says 1/2 the product of the height and the sum of the bases. So I just told you the mid-segment was half of the sum of the bases. And then we multiplied by the height of the rectangle, which was h, right? That's what it looks like. You don't even have to do that 1/2. Some people don't like that 1/2 there. They like to think of it here. Like, you know, the way we do an average, add them together, divide by 2, right? You can think of it that way. So the way that you'll see it in most textbooks is 1/2 h, parentheses b1 plus b2. Do you see where it comes from? If you see where it comes from and you understand where it comes from, you always know this formula.
Where's the height?
The height was right here. I kind of covered up with my h. Okay? So let's see. So the area of a kite in a rhombus. So you could go through this whole process as well. Basically what happens here is imagine that we extended it and we kind of boxed it in. Look at each of these pieces. Do you see how this is half of this whole thing? Yeah. And this triangle is half of this whole rectangle. And this triangle is half of this whole rectangle. And this triangle is half of that whole rectangle. Did you guys get that? So in other words, the kite or rhombus that's in the center that we had is going to be half of this distance times this distance. Half the rectangle, right? Does it make sense? What are those called? This distance is called a diagonal, right? And this is a diagonal. So it's half the product of the diagonals, half d1, d2. That's where that comes from. Do we see where it comes from? If you know where it comes from, you will have no trouble remembering this. And you will need to know these by Friday. Okay, so number 1, so it says plot the kite A, B, C, D using A is 0, 5, B is 3, 6, C is 6, 5, and D is 3, 2. Okay, so we get a kite. Do you see which sides look like they're the same? So boys, this is where your estimating comes into play. These two are the same and these two are the same. And you can find that with the distance formula if you would like to. So these two are the same and these two are the same. So if I asked you to prove that it was a kite, you'd show some mark. Can you get the diagonals? So what's the distance from A to C? Well, A was at 0, and then it goes over to C, which is at a height of, or a width of 6, right? So AC, do you guys see that that's 6 if you count over? What about BD? Yeah, 1, 2, I think maybe 4.
Yeah, my bad.
So those are the diagonals. So what's my area then? It's going to be 1/2 my diagonal 1 times my diagonal 2. Okay, the only thing that I see students mess up on every single year with this is they'll try to take 1/2 of 6 and 1/2 of 4. Okay, if I'm multiplying 3 numbers together, like if I tell you 2 times 3 times 5, we do 2 times 3, which is 6, times 5, which is 30, right? We don't do 2 times 3 and 2 times 5. You see what I'm saying? So we're going to do 1/2 of 6 is 3. So we got that result was 3, and then multiply by 4. So we should have 12. Or you could do 6 times 4 is 24 divided by 2. Okay, so it's 12 square units. All right, so how about the trapezoid? So this is the way they look in calculus. They're always on their side. Does that mess you up, or can you handle that? So if I'm trying to find my 1/2 h times b1 plus b2, my h is actually the 3.5, right? That's h. My b1 and b2 are the two bases, and it doesn't matter which one's which. Okay, so we're going to get 1/2. My h is 3.5, my b1 is 2.4, and my height is 4.6. So 2.4 plus 4.6, we get 7 times 3.5, and then divide by 2. So we get 12.25 centimeters squared. Easy enough? This is a good section to end on. It's pretty Algebra 1-like, right? It's not too bad. All right, so let's try these next ones. So you guys try 3, 4, and then 5, A and B. So see if you guys can get them. Okay, so what do we get? So number 3. So you have E, F, G, H. Make sure when you draw it, wherever you start E, you go around, and it can go clockwise or counterclockwise, but you go in that order, right? So when we talk about EG, that means that it's a diagonal. So that diagonal is 10. FH is 15. So that can be D1 and D2. So its area equals 1/2 D1 times D2. Did you guys get 75? Yep, that's perfect. All right, the next one looks like it's a rhombus added to a triangle. You guys see that? Or you could just say, oh, I have 5 triangles. And those 5 triangles all have the same area. So I don't care how you do it. You could do a rhombus plus a triangle, or you could do 5 triangles. But you end up getting 1/2 base times height, and then you have 5 of them. So you should have, did you guys get 30 as your answer? Is that right? Maybe? No? Yeah, so that's the area, right? So what's the perimeter? Did you guys get area was 30 or no?
Yeah.
Okay. And so the perimeter would be, did you guys find each of these sides were 5 by Pythagorean theorem? So we have 5 plus 5 plus 5 plus 4 plus 3. So 15 plus 7 is 22. So 22. Yes? No?
I got 20. I got 22.
Okay.
Okay.
So you have 5, 5, 5, 4, and 3.
How did you get it?
So 5 plus 5 plus 5 plus 4 plus 3. Right?
Or will you do this? Couldn't you just assume that the other one was 5?
The other one, what is 5? Like, did you add in this 5?
It's part of the shape.
Okay, guys, so you can't add in, I see the confusion. You can't add in that additional 5 because it's not on the outside of the shape, right? So if I was saying this is a building and we want to measure around the perimeter of the building, right? If I wanted to, find a fence or something that is around it, you would need that. All right, so how about this next one? So it says find the area of the composite figure. So we have a trapezoid. Did you guys do it with a trapezoid? And a rectangle. So sometimes if I have multiple shapes, I write like area of trapezoid, area of a rectangle before I add them together, just so I can kind of keep track of all my shapes. So the area of the trapezoid looks like it's going to be 1/2 h. What is this distance here? Did you guys get it? The whole distance was 10. This one was 6, right? So what's the height of the trapezoid? It should be 4. Do you guys see how that distance should be 4? Okay, so we have 1/2 h was 4, b1 plus b2. So what did you guys get for the top part of the trapezoid? It looks like 7 and 5, right? 7 and 5 make 12. And then the bottom is 15. So you get 2 times 27, which is 54. Did you guys all get that for just the trapezoid portion? Or did I go too fast? I lapped you? You guys didn't get a chance to start it, or you did start it? All right, and then the area of the rectangle is 6 times 5, which is 30. Is that what you were saying was 30? I was like, where are you getting 30, Cassie? I was really confused. All right, so then we add these together. So our total area is 54 plus 30, which should be 84. What are my units?
Inches squared.
Inches squared, perfect. All right, and the next one let's write as an exact answer. So when I say an exact answer, it means it's going to have pi in it. But let's also write as a decimal. Okay, so our area for this one is going to be the area of a semicircle and the area of a trapezoid, right? So the area of a semicircle is half of the area of a circle. So half of the pi, what's my radius?
R squared.
My radius squared, what's my radius though in this case?
10.
10. So I get 100 pi divided by 2, so 50 pi. And the area of the trapezoid is 1/2 h is going to be 14. B1 is 20, B2 is 32. So I get 1/2 of 14 is 7 times 52. So 364 on my calculator. So the total area would be adding those together. So I'd write 50 pi plus 364. And that is an answer. That is what we call the exact answer. Okay? So if I want to approximate it, sometimes I'll do the little approximation sign. So I do my 364 plus 50 pi, and I get 521.07. Well, 080 is what I'm going to do, because it was 796. And remember how I always say like 3 decimals is the best because of the AP Calc thing, right? All right, so that's the end of chapter 6. So that's everything in chapter 6. All right, on your study guide. So I just gave you the study guide. You know what I did? I left off. This is why I told you I did it in a hurry. I left off all the ones that are like, find the sum of the interior angles. Find the sum of the exterior angles, right? Do you guys remember those? I left those off, so I'm probably going to add another page to it. I know, so sad.